Hey there, Tay. Let's dive into the fascinating world of neuroplasticity, the brain's incredible ability to rewire itself. Think of neuroplasticity as the brain's way of remodeling its own architecture in response to our experience, learning, and even trauma. It's what allows us to remember, adapt, and recover. But here's a twist: sometimes this very flexibility can go awry, leading to mental health challenges like depression, schizophrenia, PTSD, and anxiety. So buckle up as we explore how this dynamic process can both help and hinder our minds. First off, neuroplasticity involves a bunch of processes like strengthening or weakening synapses, those tiny connections between neurons, sprouting new dendrites, generating new neurons, and reorganizing entire circuits. Under normal conditions, these mechanisms fuel our ability to learn new skills, form memories, and regulate emotions. But when things get disrupted, say due to genetic factors or environmental stressors, like chronic stress or trauma, these plastic changes can turn maladaptive. Let's talk about the molecular level. Imagine your brain's plasticity toolkit. Two key players are LTD and LTP, long-term depression and long-term potentiation. Think of LTP as turning up the volume on certain neural signals, strengthening those connections, while LTD is like turning the volume down, weakening them. These processes depend on activity-dependent signaling through receptors like NMDA, calcium ions, and kinases, such as CANK2. Normally, this fine-tuning helps us encode memories and adapt behaviors. But if these signaling pathways go haywire, it can lead to circuits that are either overly excitable or too weak, setting the stage for mental health issues. Another important piece is brain-derived neurotrophic factor. Think of it as a fertilizer for your neurons. It promotes growth, survival, and plasticity. When BDNF levels drop, as seen in depression, the brain's ability to adapt and heal diminishes. Interestingly, environmental factors that present changes in gene expression can all influence BDNF and other molecular cascades, shaping how our brain responds to life challenges. And it's not just neurons. Glial cells like microglia and astrocytes are key players too. They output the necessary synapses and maintain balance. But chronic inflammation or neuroinflammation can throw a wrench into this system, impairing synaptic remodeling and neurogenesis, which may contribute to various psychiatric conditions. Now let's see how this plays out in specific disorders. Depression, for example, studies show how reduced hippocampal volume and impaired neurogenesis. Chronic stress floods the brain with cortisol, shrinking dendrites and reducing synapses formation in regions critical for mood regulation. Low BNF levels are linked to severity, but interestingly, antidepressants and even rapid-acting agents like ketamine can boost plasticity markers, helping the brain bounce back. In schizophrenia, the story involves excessive synaptic pruning, like the brain throwing out too many connections during development, potentially mediated by immune molecules like complement proteins and microglia. This overpruning can disrupt brain networks, leading to cognitive and perceptual disturbances. PTSD and anxiety tell a different tale. Here, the amygdala, the brain's fear center, is hyperactive, while the hippocampus' ability to form new, saved memories is compromised.